Hello everyone. In this video, we will walk through the complete step-by-step process of using Xilinx 2019 version to design and simulate and implement the D flip-flop on Artix 7 FPGA hardware board. I am Dr. A.Murali, working as Associate Professor in Department of ECE with College of Engineering and Technology. Let's start. D flip-flop. It is also known as data or delay flip-flop. D flip-flop is one of the most commonly used sequential logic circuits in digital electronics. It stores one bit of data and works as a memory element in synchronous systems. D flip-flop captures the value of the input data at the active clock edge. Maybe it is rising edge or falling edge, that depends on the design, and transfer it to the output Q. The output remains stable until the next active clock edge. D flip-flop truth table and its block diagram. So it has one input, that is D, data in, and one output Q, output data, and also clock signal. We are applying the clock signal, that's either negative edge clock or positive edge clock, and initially we do the reset. So when we are giving the rising edge, whatever the data we have, the same data will be reflected at the output stage. If data is 0, the output will be 0. If data is 1, the output is 1. And if there is no edge clock, the output will be previous state only. Whatever the previous output, that will be reflected here. On the clock edge, Q follows the data D. Between the edges, Q holds its last value. The logic equation for this, Q next equal to D. Excitation table and logic diagram. Logic diagram, D flip-flop using 2 input NAND gates, and also it is implemented from SR flip-flop. This is the excitation table. There are some applications: data storage, 1-bit memory cell, shift registers, serial to parallel or parallel to serial conversion, and also designing counters with proper arrangements, synchronization, that means to avoid the metastability, and state machines to store state information. Now let's start Verilog code for D flip-flop. Model D flip-flop, input data, input clock, and input reset, and output Q. Always set the rate of positive edge clock or positive edge reset. This is behavioral modeling code. Begin if reset, that means if reset is high, Q output equal to 1 tick be 0. So reset output to 0. Else, if reset is 0, now output Q equal to D. So transfer the data to output on the clock edge and model. This is the disturbance code. So here the inputs are changed to registers and outputs are changed to wire. Instantiates the D flip-flop model. So whatever the variables here, the same variables I am giving here, dot D of D, dot clock of clock, dot reset of reset, dot q of q. And clock generation. So this is the clock generation code. Initial begin clock equal 0 forever as 5 clock equal to negation clock into positive edge and negative edge. And so this is the monitor output. I want to display all these values, and these are the conditions. D equal to 0, reset equal to 1. After 10 time units, reset equal to 0. These are test sequences. D equal to 1 after 10 seconds, D equal to 0. So here we are expecting Q equal to 1, Q equal to 0, Q equal to 1. A reset. Finish and end model. Now let's start the simulation. So let me quickly complete this. Start by launching the Vivado 2019 from welcome screen. So here click new project. So go to file, project, new, or so here create a project. Anyone you can select, new. Then click on next. So give the project name here. I'm giving the DP block. Then next. Then next. So if you want to verify the result on the hardware board, you have to choose here Artix 7. So here I am using board is FTZ 256 and initial speed is -1, and my board is XC 7A35 TFTZ 256. Click on next, then finish. Now we will add Verilog code. So for this, under the project manager, click on add sources. So click on add or create design sources. Next, and create file. So D flip flop. Okay, then finish. Simply okay. S. So here file is created. File name. Double click on the file name. Then I want to remove these things, comment lines. So for time purpose, already I have written code. So directly I will copy paste here. For time saving. Then save. Disturbance code. Save. Then go to run simulation. Run behavioral simulation. So something errors are there. So here I want to change name. Here also I want to change. Yes. Okay, now see the output waveform. So this D input clock signal and reset output. If reset is high, the reset is high, whatever the data we have, the same thing reflected in the output. And reset is low, at the positive edge of the clock, whatever the data we are sending, that is reflected at the output stage. See this. Now see the RTL analysis. So click on the schematic. So this is the RTL schematic diagram generated from the tool. Now so here I have written test bench code in the same file. If you want, again we can create the add sources. If you want to write the separate file for the test bench, click on add sources. This time you can select this one, add or create simulation sources. Auto nest, create file. Of underscore tb. Finish. Okay. Yes. Sources. Simulation file, this one. tb. Stay. So here you can write Xilinx code and you can simulate from here. Save. Now go to sources. This is our test bench file. For the previous program. Thank you guys.